viewers, welcome back to our YouTube channel. In this video we are going to do our first machine learning project in supervised machine learning by using regression model. So we are going to apply bunch of regression models. So I have divided this video in several parts so that you can understand each regression model deeply, so that you can implement these models in any of the data sets or in any of the problems. So first I took the problem statement, which is bike sharing demand prediction. So we are going to apply our each model on this particular data set. Before applying, we are going to do our EDA, exploratory data analysis. After that, we'll visualize our data and we'll get some idea of our data. Then we'll implement our models on this particular data. So let's begin. First, we are going to understand what is machine learning. For this purpose, I'm going to tell you one frictional story. So let's see. Once there was a doctor. He would look at a person and predict if she or he has lack of hemoglobin or not. And almost all the time his prediction will come true upon testing the blood of the patient. How would he predict? Let's assume pale color of face, tidiness in body are symptoms of low hemoglobin. If the weight of the person is less, then more chances such symptoms are because of low hemoglobin. The doctor would, upon his past experience, will predict after looking at that person. What if we can make computer also learn things like this and make such prediction? Assuming we have numeric quantified variables like paleness and tiredness. So I think you have understood what is machine learning with this frictional story. So now we'll begin our journey by doing our EDA and understanding the data. For this purpose, I am going to use Google Colab Notebook. So let's begin. As you can see, this is our problem description. First, we will go through this. Currently, rental bikes are introduced in many urban cities for the enhancement of mobility comfort. It is important to make the rental bike available and accessible to the public at the right time, as it lessens the waiting time. Eventually, providing the city with stable supply of rental bikes becomes a major concern. The crucial part is the prediction of bike count required at each hour for the stable supply of rental bikes. So this is our problem statement. So now we are going to see data description. The dataset contains weather information like temperature, humidity, wind speed, visibility, dew point, solar radiation, snowfall, rainfall, the number of bikes rented per hour, and date information. So these things you can see. So first we are going to load dataset and the couple of modules. As you can see, I'm going to import these things first. So these are important to convert our date, so we are going to convert our date into month, hour, and all those things. So for that you need to import these two modules. So yeah, these things you can import accordingly. So for now you can just import these things. Okay, then we are going to mount our dataset, right? It will just take few seconds to mount. As you can see, it's just loading. Just wait for a few seconds. Now I'm getting the dataset from the drive, as you can see. So let's see how our dataset is. As you can see, so I'm just going to tell you how to convert this column, right? So before that, we'll see all the other columns. Rented bike counts. This is a dependent variable and the rest are independent variables. So hour, temperature, humidity, wind speed, visibility, dew point, solar radiation, rainfall, snowfall, seasons, holiday, functioning day. So here you can see functioning day, holiday, seasons. So these are categorical variables which are very important for us. And yeah, let's move on. Let's see the tail. Okay, let's see the shape. So these are the rows of data which we are having, 8760 rows of data and 14 columns. So these are the columns. So this is the info of our data, and so as you can see, these are the unique values which we have. So these are the categorical variables, seasons, and so this is the description of our data set. So you can see mean value, standard deviation, minimum. So this is the first quartile, second quartile, third quartile, maximum values. So you can just see them. So this is a future description. So what we are going to do is that, so we are going to take this by like the date column. So yeah, let me show you what I'm going to do. Before that, here you can see the missing values. We don't have any missing values, by God grace. Okay, if they are there, no, we need to do a lot of things. So we are going to do another thing. We are going to check the duplicate values with this code. So we don't have any duplicate values. Here we are changing the column names, so for our convenient. Okay, then here you can see, so now what we are doing, we are just going to break this date column into year, month, day. So by using this thing, you can use whatever you like. Okay, and then what we are doing, we are going to create a new column, weekdays, weekend, and drop the columns date, day, year. So we are going to do one thing, right? So what we are going to do, we are going to create a new column, so called weekdays, weekend. So if it is Saturday or Sunday, it will give 1, not means 0. Okay, here you can see. So just going to run this thing. In this particular thing, I kept month column and weekdays, weekend. Okay, now you can see weekdays, weekend. So yeah, I'm just going to use a value counts to get this thing. Yeah, it's table data only. Okay, no issues. So we are going to change some these columns, right? 1 minute. So these columns are in integer type, weekdays, weekend, and so some are in object type. So we are going to convert them into categorical. So let me run this thing. Okay, yeah, hour, month, weekdays, weekend. So we are going to convert them into categorical variables, as you can see. Okay, and let's run this thing. Now you can see weekdays, weekend, we are having only 2, 0, 1. So yeah, I'm just going to run this. Okay, now we are going to do exploratory data analysis of the data set. Okay, so for this thing, I did this thing in Tableau. So for better understanding, I'm going to show you all these things in Tableau. Okay, I'll give you the link to Tableau. So what I did here, I have done the same things in Tableau also. Okay, So this is my dashboard. You can see dashboard also, no issues. Then let me show you each sheet. So the first one is count of rented bikes according to the month. So you can see in the sixth month we are having more number of bikes rented, right? In the month of June, sixth month means, okay. In second sheet you can see count of rented bikes according to weekdays and weekend. So according to us, 0 is weekdays and 1 is weekends like Saturday and Sunday. So we are having more number of rental bikes on this on weekdays, okay. Next, count of rented bikes according to weekdays and weekends. So with respect to hour, so as you can see these things. Okay, next we are moving with count of rented bikes according to hour. So 18 hour, okay. At this time we got more number of bike rentals, right? 18th hour. Eighteenth hours mean 6 o'clock, like that, okay. Okay, here count of rented bikes according to functioning day. So on functioning day only we are having rental bikes, okay. So on this day only we are able to rent our bikes. This is the same thing. As you can see, we don't have any count of bikes on no functioning day. So this is respect to seasons. So in winter we are having the least amount of bike rentals. In summer we are having the most number of bike rentals, okay. So count of rented bikes according to seasons, same thing with respect to hour also. You can see this thing here, count of rented bikes according to holiday. So on no holiday we are having more number of rental bikes count. On holiday we are having least, okay. Here you can see count of rented bikes according to holiday, the same thing with respect to hour. So you can see this dashboard and all these things, okay, no issues. And with that we finished till here. Analyze of numerical variables. What is numerical data? Numerical data is a data type expressed in numbers rather than natural language description, sometimes called quantitative data. Numerical data is always collected in number form. Numerical data differentiates itself from other number of form data types with its ability to carry out arithmetic operations with these numbers. So these things you can see, okay. Analyze of numerical variables using dist plots, okay. You can see this thing with the density and rented bike count, with the temperature and density, humidity, density, wind speed, density, visibility, density, dew point temperature, density, solar radiation, all these things you can see, okay. Numerical versus rental bike counts. So in this case, temperature with the mean of this rented bike counts, dew point temperature with respect to this rented bike count, all these things you can see. Okay, so from this all figures we can say that rented bike is uniformly distributed despite of wind speed, but when the wind speed was 7 meters per second, then the demand of bike also increases. That clearly means people love to ride bikes when it is little windy. So no one likes to ride bike when it is too much of windy, right? So you can just go through all these things. Then we are going to plot a regression plots. Okay, these plots will be very much helpful to create regression models. Okay, the regression plots in Seaborn are primarily intended to add a visual guide that helps to empathize patterns in a data set. During exploratory data analysis, regression plots, as the name suggests, creates a regression line between two parameters and helps to visualize their linear relationships. Okay, so here you can see rented bike count and rented bike count. That's why we are getting this line. Okay, here you can see this is positive linear relationship we can see. So this thing is not okay, this thing is not, yeah, positive relationship. So this is a negative relationship. From the above regression plots of all numerical features, we see that the columns temperature, wind speed, visibility, dew point, solar radiation are positively relation to the target variable. Okay, let's see again. Temperature, wind speed, visibility. Temperature, so temperature, this is a positive relation. Then so this is not positive relation. Okay, wind speed, yes, and visibility, yes. So as you can see, all these things are positive. It's like this. Okay, this thing is, yeah, positive relation. Yes, positive relation. These are negative. Rainfall, so when rain is coming no one wish to go, right? So that's a basic thing. And snowfall, when there is a snowfall no one goes, right? Normalize rental bike count column data. So we are going to normalize this data. The data normalization, also referred to as a data pre-processing, is a basic element of data mining. It means transforming the data, namely converting the source data into another format that allows processing data effectively. The main purpose of data normalization is to minimize or even exclude duplicated data. So these are the things. Here you can see these are outliers. So yeah, we are going to remove them. Here you can see after removing outliers our data, and yeah, let me run these things. Okay, not means, okay, no need to run, because from, okay, here you can see this is the correlation rented by counts. All these things are correlation. So close to 1 means highly correlated, highly positive correlated. Close to -1, highly negatively correlated. Okay, so which are positively correlated and which are negatively correlated, we can take them. Okay, so yeah, checking for correlation between variables, checking in OLS model, ordinary least squares. Regression is a statistical method of analysis that estimates the relationship between one or more independent variables and a dependent variable. So these things we are going to see. Then let's move on. So after that you can see correlation. So heat map will help us to visualize this correlation. Okay, here you can see close to 1. So here 0.8 is good, dew point is superb good, right? Dew point is superb good, the temperature, and 0.54, this is also good, 0.54. You can take 0.54, these columns you can take. So you can see, we can observe the heat map that on the target variable line, the most positively correlated variables to the rent are for rental bike counts. We can see temperature. For rental bike count we can see temperature, then dew point temperature, and the solar radiation. So yeah, you can see here 0.9 is for dew point temperature to temperature. Okay, for we want for like dependent variable, right? So we took these things: temperature, dew point temperature, solar radiation. And most negatively correlated variables are humidity and rainfall. Most negatively correlated, minus 0 point, okay, which is rainfall, and humidity. Yes, humidity. So from the above correlation heat map, we see that there is a positive correlation between columns temperature and dew point temperature. So that is 0.91. So this is what I was first told you about dew point temperature and temperature, which is like that. Okay, and if you drop this column, I don't affect the outcomes of our analysis, and they are the same variations. So we can drop the column dew point temperature. So we are dropping it. Okay, so yeah, you can see we are just going to drop this thing. After that we are having this create dummy variables. A dataset may contain various types of values. Sometimes it may consist of categorical values. So in order to use those categorical values for programming efficiently, we create dummy variables. Okay, categorical features. So these things we took. Okay, hour, seasons, holiday, functioning day, month, weekdays, weekend. So one-hot encoding. Then a one-hot encoding allows the representation of categorical data to be more expressive. Many machine learning algorithms cannot work with categorical data directly. The categories must be converted into numbers. This is required for both input and output variables that are categorical. So you can read about one-hot encoding more by just googling. So if you don't understand anything in between, you can just google them, and after understanding little bit also you can just implement this thing. Okay, no need to think about it. Okay, model training. So we are going to split our data set into train and test split. So you can see this. Yeah, so yeah, for testing we are giving 25%. Okay, for training we are giving 95% of our data. Then you can see these are the columns. Okay, next. So now we are going to do our first regression, that is linear regression. First we are going to apply, so particularly in this part, so this is our first model. So in our upcoming parts we are going to apply another regression models, but this is for this video, this is the one which we are going to apply. Okay, linear regression. To know more about linear regression, you can read this article in Geeks for Geeks. Okay, so this is a formula: y equals to theta 1 plus theta 2 into x. So there are many more formulas which kind of look like this only, but in place of theta 1 there will be y equal to mx plus c, like that, and y equal to a plus b into x. So there are a lot of formulas here and there. Okay, here particularly here you can see y equal to theta 1 plus theta 2 into x. Here theta 1 is intercept and theta 2 is coefficient of x. Okay, so these things you can read to understand about this linear regression model. So, and the rest of the things are very easy. So we are going to import this thing from scikit-learn linear model, import linear regression. So yeah, first what we are going to do here, we are going to fit the training data set. So we are just fitting the training data set after creating our linear regression model. Then we are going to check the R-square score on training data set. Then this is a coefficient. After that we are going to predict on training data set as well as our testing data set, as you can see. Then so we are going to check all these things: MSC, RMSC, MAE, R-square, adjust R-square. So you can just consider R-square. Okay, no need to bake your brain to understand other things. Okay, just understand R-square. So R-square must be near to 1. That means that our model is performing good, well and good, if it is near to 1. Okay, here 0.772 is well and good. Okay, our model is performing, that means. Okay, so yeah, here you can see. So this is a negatively correlated plot, as you can see. Yeah, these plots you can see. So in our upcoming video we are going to see lasso regression. So no need to remember all this code. Okay, just Google it and copy paste it, no problem. No one will care about it. Okay, just remember my words, just understand the problem statement and what you need to do. That's it. Okay, and that's it for now. I hope you like this video, and if you like this video, don't forget to hit the subscribe button and like this video and share it with your friends. And if you have any doubts, please mention them in the comment section below. I will just reply them. Okay, and that's it for now. Bye bye.